There we go. All right, it's running. Cool. All right, let me share my screen. Share. There we go. Hide. Okay, for those who just walked in, the first session is already on the YouTube channel. It's just the first video on what to watch next. If you go to the YouTube channel, that's everything we covered this morning. All the audio, everywhere we went on the screen, it got recorded. I'm recording the current session right now, and it'll be posted immediately after this. Before we move on to CFA, I just want to make sure that nobody had any thoughts during lunch that they want to bring up, answer any questions before we move on. I'll let you think for a sec. There's one more thing I wanted to show you with an EFA that I forgot to show you. Thanks to Dino for showing me during lunch. In your EFA, there's a way to collapse all the indicators for a factor into a single score. It's called a factor score. And so instead of having, for example, where's our output here? Go up to the pattern matrix. Here it is. Instead of having 8 EOU items, variables, we'll have 1. And it's better than an average because what it does is it weights the average based on the loading of each item. And so it's a weighted average based on those loadings right there. So what you do to get that is in your analyze dimension reduction factor, in your factor analysis, in the scores area, you would click save as variable. There are 3 different methods. I'm going to use the regression method. Why? Read Hare et al. He'll tell you why. Hit continue. So when I hit OK, this is going to create 4 new factors, one for multi-purposing, atypical use, anxiety, and system satisfaction. Hit OK. And if I go over to my data set, you'll see I have a new variable, 4 new variables, excuse me, down at the very bottom. Each of these represent one of the factors. And then I can just rename those to whatever they were. And use them then in regressions, in ANOVAs, t-tests, whatever I want to do with them. That's one thing you can do. Hope that's helpful. Go ahead and delete those. Oops, escape. Clear. There's clear. Okay. All right. So that's EFA, a necessary precursor to the CFA. I get emails again every day. People say, hey, my CFA won't work. Fix it for me. And so I mess with it, and I can't fix it. And so what I inevitably end up doing is I go back to the EFA. And I realize, well, the EFA is garbage. And so that's why the CFA won't work. You've got to work out the EFA first if you want the CFA to work. You can't just skip it. So we worked out an EFA. Let's pick one. I don't like these variables very much. I'm going to get rid of these. Yes? The regression method. I always do. I'm not sure what the most correct answer would be. It probably depends on context.
So are there any cases that you would rather use for that or
if there are, I don't know what those contexts might be. There is a model we're going to be playing with tomorrow. Let me see what it is so that we can be consistent. Okay. And then we use those variables from that model. So in our folder, slides, structural models. This will be tomorrow, but I want to see what model we're going to work with. I changed it for this boot camp. It's not the one I usually use. Okay. Playfulness, comprehensive use, atypical use. Let me throw these in here. Playfulness, comprehensive use. What I'm going to do, you don't need to follow along for this one, because I'm going to use a tool that you don't have, unfortunately. And then I'll save it to the folder, and then you can draw from it. So give me a moment. Atypical use. But I want to show you what it does. Otherwise, I would have just done this during lunch. No. Usefulness, enjoyment, info acquisition, decision quality. Okay. Usefulness. Enjoyment. This is going to be a big one. Information acquisition and decision quality. Now we learned that decision quality 11 and 13 are garbage in this context, I believe. I'm going to run this one more time just to make sure it works, and then we'll turn it into a CFA. So again, don't follow along. I'm just going to just make sure this is clean. Looks pretty good. Yeah, looks fabulous. Okay, so what we're going to do is you want to turn this into, not this, but into this. You want to go from your pattern matrix to a beautiful CFA. So that's what we're going to do. Unfortunately, Amos is not optimized to do this, even though it is the software used to do it, which is inconvenient. I'm going to open up Amos, make sure your Amos is working. It should just be down at the bottom there on your toolbar. Amos graphics. Okay, has anyone ever used Amos? For those of you who have used it and are fairly familiar with it, this next part's going to be extremely painful because I'm going to go so slow. For those of you who've never used it, it's going to be extremely painful because it's really not user-friendly. For those of you who've used it before, you know what I'm talking about. So please just bear with me. I'm going to get us through with as little pain as possible. What you want to do is open up a new file. File new, unless you already have a clean canvas, then you should just start right here. The first thing you want to do once you have a clean canvas is you want to pull in the data set you're going to be using. We'll be using the bootcamp data set. Shouldn't be any real changes on that from what you have. So the way you pull in the data, you go File, don't click on Open because that would be intuitive. What you're going to click on is Data Files. File Data Files. And that's how you link a data set to your Amos canvas. This opens up a dialog. Click on File Name to go find that data set. Where's that data set? It's wherever you saved it. If you're using a campus computer, who knows where it got saved? Is it in the Downloads folder? It's in the Downloads folder. How do you get to the Downloads folder? On the left side of your screen in the open dialog box, there should be a thing that says My Downloads, or you could go to Recent Places and it would be there too. If you can't find it, ask the person next to you. And if you still can't find it, then let me know and I'll help you find it. Okay. Get the data. Your data. Your data download. It's not your downloads folder. Lovely. All right. Go to desktop. Okay. And hey, there it is. Yeah. Yeah. Click on hit open. Yeah. Anyone else? This is a critical first step. If you don't get this, you won't be doing anything with you. So. Okay. Anyone else? So once you have that located and you click open, what will happen is it'll show up right here under group number 1, bootcamp original.save, and it'll show you your N. Your N is your sample size, so we have 381 respondents in this sample. Hit OK, and nothing happens. And so you just have to assume it worked. Now, what you want to do is build a CFA. It is incredibly painful to build a CFA. Let me show you how you might do it by hand. I'm not going to have you do this. You click on this little candelabra thing, or maybe Wolverine claw thing, and then you come out here, draw, click, 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 click. I think we have 8 on one of them, 9 on. Anyway, it's really, and then you got to order them and then drop the variables into every single one of them, and then it's just a pain in the rear. So I had a student just make a plugin to do it automatically. Let me go grab my data again. So what I'm going to do is I'm going to make the file for you, save it in the Dropbox folder, then you guys can go grab it. Here we go. And you'll see why we had the student do this. Okay, in SPSS, my output, oops, here it is. So all I'm going to do is I'm going to grab the pattern matrix, and you guys can, on your own machines, you can download the plugin and install the plugin. I have a video that shows how to get the plugin and where to put it, so you guys can do it on your own machines. You just can't do it on the campus machines because they won't let you install driver files. Anyway, but I would just copy the pattern matrix, go over to Amos, go to the plugins, drop down, and I have this fun drop down called Pattern Matrix Model Builder. Just paste the matrix in there. If it lets you. Doesn't want to let me. Copy special. It's trying to copy it as a picture file. There we go. We'll go in that. Save as default. There we go. And now go back over, paste, and create diagram. And this will automatically create the diagram for you, which will save you so much time, especially if you make errors when you're creating your diagram. Let's hope this works. Just thinking about it. Please work, please work, please work. It's always lovely when you do live demonstrations and technology fails. It should work. Honestly, it should work. I've done this before. Yeah, it could take several minutes. We have a fairly large. Hey, there we go. Ta-da! There we go. So I'm gonna clean up this file a little bit, save it. You guys can download it. What this did was it took. Let me zoom in. To zoom in on Amos, you just scroll up in the canvas area. Yes.
So we don't have this on the Amos.
No, you don't.
We have. So it's better for those who've never done it.
Learn how to build it.
Yeah.
But you can download the plugin on your own device, on your own laptop.
From where?
I'll show you. Yeah. Real quick. So for those who would like to download the plugin onto their own laptop or wherever, you can go to actually just on my channel here. If you search for EFA to CFA plugin. There it is. There's a video showing you how to do it, where to get it, what to click on, and it'll tell you exactly how to go about getting that set up. I go in here. But again, if you couldn't get that to work, the traditional way is you use the candelabra to build each of these little things, and then you would go into this white stacky thing, which has your variables in it. And you would then go find, let's see, usefulness. Where are you useful? You drag useful 1 into this box, and then useful 2, and then useful 3, and so on and so on.
Can you maybe develop 2 constructs with 3 indicators?
Just to show how to do it? Sure. I'll do that. Let me save this first so everybody can have access to it. But before I do, I'm going to just rename things. Right now they're named 1, 2, 3, and 4. Terrible names. Just going to rename this to, I just double clicked it. I'm going to rename it to useful. Name this one to enjoy, playful, decision quality, a tip use, info, and comp use. Okay. The last thing I'm going to do is you'll notice there's a constraint, a parameter constraint of 1 on one of each set of indicator regressions. Amos requires this in order for the model to run. But that constraint can be on any one of these lines, or it can be moved out to here, to the latent variable. I would prefer it out on the latent variable so that it doesn't give unfair weighting to any of the indicator lines. So I'm just gonna move that real quick, then I'll save it and you guys can have it. So to do that, just double click this, parameters, and get rid of that one, delete, 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 oops. Yeah, parameter constraint is when you force a certain parameter, such as a regression, to have a certain value. So what this is doing, when you stick a 1 on that, it says force the slope, force the relationship that is represented by this line to equal 1. So an exact 1-for-1 relationship. So that forcing is an artificial forcing, right? And so it gives an unfair weight to that particular line. So instead I push it out to the variance here, and we're saying force the variance to equal 1. Now, whether you do this or not, you're going to end up with roughly the same results because these constraints apply primarily to the unstandardized model, but we're just going to be looking at the standardized model anyway, which will make a lot more sense as we go through this. Unstandardized versus standardized. Let me save this, send it to you guys. Let's see, Dropbox, there it is. SEM Bootcamp UCF, Amos, and I'll save it here. This will be the first file in the Amos folder, CFA initial. Save. It will then sync with Dropbox. It is currently syncing. Still syncing. You guys should have access to it fairly soon. Amos. There we go. The AMW file is synced. It has been synced with Dropbox, so you can go download that. You'll have to refresh your Dropbox browsing window. Now, I'm going to go back to what Osley has asked for. I'm going to build one from scratch. Just a very simple one. Yep. So new, pulling the data like before. Okay, let me see. I'm going to build one for usefulness and decision quality. And I'm just going to say each one has 3. Oops. Here's a common mistake. If you're building by hand and you just click, it creates these, whatever the last sized variable you drew was, it'll create it of that size. So that's a problem, especially if your last variable was a single pixel by a single pixel, because then it gets invisible. So what you want to do is click and drag for your first one, and then click, 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 click. And then I'm going to rotate using this rotator thingy. Rotate, rotate. And then I'm going to move it with this fire truck thingy. But not just the fire truck. My fire truck has to have balloons on it. So I click on this balloon thingy, and then I can move it all together. If I don't have the balloon thingy with the fire truck thingy, then this happens, and that's no good. So there's a Control Z and Edit Undo down here. I have to have these covaried. You may have noticed in my other model, every exogenous latent factor was covaried. That's an assumption in Amos. They just need to be covaried. Why? Amos is a covariance-based structural equation modeling software. And since it is covariance-based, it needs a covariance matrix to work with. If you don't covary the exogenous factors, you're depriving it of that opportunity. So covary those exogenous factors. Then I would drag in or type. You can also type in these variables. So I'm going to drag usefulness 1. That's a good mess. Usefulness 2, and I'll show you how to fix it. Usefulness 3. And then let me go infoac 1, infoac 2, infoac 3. And then in order to fix this mess, you go to View, Interface Properties, Miscellaneous, Display Variable Labels. I'm glad this is all being recorded, so the steps are all here for you. You uncheck Display Variable Labels, hit Apply, changes it to variable names. Super intuitive, right? And then it's still a mess. I'm going to go to Plugins, Resize Observed Variables. All observed variables are rectangles. All unobserved variables are ellipses. So now they're all the right size. I'm going to name my unobserved latent variables as useful and infoac. And then I also have these error terms which have to be named. Plugins, name unobserved variables, and it automatically numbers those for me. When I learned how to do this, my instructor didn't know about all these useful tools, so we built it like this. We grabbed a circle, and then we grabbed a box. Oh, that's too big. Anyway, we drew each box in each circle, then we placed each constraint, and then each error, and then named everything by hand. It was just painful. Anyway, that's why I learned the easy way. Okay. Anyway, that's how you'd build one by hand. And then you'd figure out where the errors were that you made and try to resolve those. I prefer the other way. Okay. Is that CFA initial coming through? Was everybody able to get it? Cool. Oops, cancel. There it is. Okay. Does anyone need help getting it in?
Can you also show the covariance plugin?
Oh yeah, sure. I forgot to show you that. Yeah. Okay. If you're building by hand and you have more than 2 or 3 factors, adding these covariances can get pretty tedious. So let me throw a few in here. Let's pretend I have 4 factors, and I want to select with the pointer finger these factors. Then I can use a plugin to draw covariances, and that'll draw them for me, which is a big shortcut for doing it by hand. It only draws them, omits the ones that are highlighted in blue. Again, to highlight, use the blue or the pointer finger. There we go. Okay, does anyone need help getting the CFA model up and running and working? Okay. Don't be shy. All right. So the CFA is good for a lot of things. In the CFA, we're doing something different from the EFA. I had this question I answered over lunch, actually. Somebody emailed me and said, hey, why are we doing a CFA if we're doing an EFA? It's like we're building a house with the EFA, and then we're testing whether we have a house with the house. Because the CFA just does the same thing. I don't think I conveyed that properly, but that's what he said. He says the EFA and the CFA do the exact same thing. Why are we doing both? And the answer is they actually do something quite different. In the EFA, we're fully unconstrained. We're saying, here's a basket of items. Find the groupings. And it iterates through and finds groupings naturally based on the covariance matrix. In the CFA, we say, here's a latent factor. It consists of these items. right? And it says, right, or no, you're wrong. And we say this latent factor is to some extent correlated with this latent factor. Now in the EFA, we see that as well. We see that some factors are correlated. You remember the factor correlation matrix at the very bottom of your EFA says to what extent each factor is correlated. Well, that's what we're going to see here, almost the exact same numbers actually. And the loadings that will be on each of these lines are going to be almost the exact same numbers as the loadings from your pattern matrix. But the difference is, again, we're saying these items belong to this factor. They belong together, and these items belong together, whereas in the EFA, we had no such constraint. It just figured it out. Yeah.
I saw that question yesterday, and actually most of the reviewers and this author their study have the same point of view. They say if you already refine your model with the EFA, using CFA, of course, you're not going to get anything crazy because you are not writing with your theory, you are going with exploratory results. So just in case we have to do it, because most of the case they, get the paper back, so we have to run it in 2 different samples. Right. Let's say if we use a training sample for the EFA and the test sample for CFA, and we don't have enough sample size, which one we should divide as each sample to do the CFA or the EFA?
All right, so this is sort of multiple points here. A lot of journals strongly recommend you use a holdout sample for the CFA. So let's say you collect 500 Rosen data, 500 respondents. You would use something like 200 for the EFA, use 300 for the CFA. Typically, we use a larger percent for the CFA. To answer that question, the most common approach, though, is you use the whole sample for both, because typically you don't get 500, you get 150, or maybe 200, lucky you get 300. Anything less than 300, it's hard to have a holdout sample unless you have a really small model. So one thing you could do, if you still want to be rigorous, but you need to use most of your sample, you could take a random sample of 70% of your data for the EFA, and then take another random sample of the entire data set of 70% for your CFA, and then you can say, well, this is more rigorous than using the whole sample for both. Yeah. But again, most journals, unless you have a really anal reviewer that's just with statistics, love those people, they won't ask you to do a holdout, for the most part. Also, in the CFA, we do a lot of different stuff. In the EFA, we have one measure of model fit. There's just a chi-square of degrees of freedom. In the CFA, we have dozens of measures of model fit to say whether our model is a good representation of the relationships among variables. We'll talk about model fit more in a little bit. We are able to do invariance tests to see if, for example, males and females had similar distributions on the way they responded to these variables, which is very important when you're then going to go do a moderation or multi-group analysis between gender or whatever groups you have in your data. You can do a method bias test. I hate method bias, but you have to teach it to the reviewers that support it, where you can see to what extent was the variance in your model explained by some external third factor unexplained in your current model with the variables you chose. We'll talk about CMB a lot more. But that's something you can do in a CFA. You can also do that in EFA, but the test for it isn't very robust. What else do we do in a CFA? A whole bunch of stuff. We're going to get to all of it. But those are the main things. Yeah. And then, of course, assess convergent discriminant validity and reliability. So, yes.
You moved your constraint from regression
Yes.
to covariance.
Yes.
Is that because you have multiple covariances between multiple constructs? Would you do that if you had only 2 constructs with 1 covariance?
Question is, why did I move it, I suppose, and under what conditions should I move the constraint from regression weight to factor variance? The main reason I move it, there are 2 main reasons, I suppose, to move it. The first is putting it here provides an unequal constraint on these indicators. Only one of them has a constraint, whereas putting it here, it's distributed equally. The second is when you go to do invariance tests, which we'll do later, if you have a path constraint here already, then you have to move it anyway. Otherwise, you can't compare this line for males to this line for females, or whoever you're doing.
So in layman's terms, it's like equal opportunity for each of those indicators.
Yes, equal opportunity, and it saves us an extra step later. Yeah. It allows us to analyze more fully.
So then what do you do when you have only two constructs?
Same thing.
Covariance?
If you only have two constructs with one covariance, you do the same thing. Notice I didn't place the constraint on a covariance. I placed it on a variance. Yeah. So the latent factors have variances. The latent factors share covariances. Yeah. So let's go through and do it. And then whatever we miss, we'll see in the slides, and I'll make sure to cover. You'll have this model, but beyond this, you need to make sure you go and link the data again, yeah? So if you click on File, Data Files, make sure it says Group Number 1 Bootcamp Original.sav. If it doesn't say that, you won't be able to run the model. So remember, try to go find that data again. I'll often get emails with the model file, but no data file. They want me to run their model. Yeah. Oh, yeah, File, Data Files. Yeah, let me hit cancel. Go to File, Data Files, or Control D. I think that 10 does it too. Yeah.
You want to mention that your plugin is not used for just two components, it's just used the maximum value?
It actually works for all of them. Okay, so the question is, does the plugin, the CFA or EFA to CFA plugin, work for all rotation approaches and extraction methods? The answer is I'm pretty sure it works for all of them. The caveat is if you're on Windows 8, sometimes it doesn't work. If you're on a Windows side of a Mac, sometimes it doesn't work. And
the component balances, there is no pattern.
it's a rotated factor matrix.
You can use it.
Yeah, you can use it for that. If you're on a comma instead of decimal system, so like a lot of countries use a comma instead of a decimal, then it will break. So you need to make sure it has decimals. Also, if you have variable labels in there instead of variable names, it will break. It's not very robust, huh? That's terrible. I didn't write it. Had a student write it. I'll take responsibility. So just make sure you're using variable names and decimal system, and you're fine. And make sure you're not using Windows 8, because it stinks. Okay. Otherwise, build by hand, the good old-fashioned way. Okay. Okay, does anyone need any assistance? We're good? Moving forward? Okay, moving forward. So the first thing we want to do is click on this. This is actually an abacus. I asked somebody who knew, and they said, yeah, that's an abacus icon. It's a colored abacus. There's another abacus right next to it that's not colored. We want the colored abacus. That gives us the analysis properties for this model. And then we want to go to the Output tab. This is going to, again, feel a lot like TurboTax. Click on the Output tab. We have a bunch of options. There isn't a set of options you always want to have checked and always don't want to have checked. It depends on the analysis you're doing. For our initial CFA, we're going to check minimization history. Standardized estimates are very important. And then modification indices down at the very bottom, which we'll talk about later. Most important at this point is just standardized estimates. Again, this is being recorded, so if you forget, it's right on the video. We'll close that. There's no OK button or apply button because that would be intuitive, right? You just have to hit X and hope it remembers your settings. And then save it just to make sure we're good. Save it. I hear some errors, so go save it somewhere where you're allowed to save. Probably when you downloaded it, it went to a temp folder, so you'll need to go save as, file save as, somewhere you're allowed to save. This is a massive model. And then once that's saved, you want to click on the not colored abacus. and that will run your model. And once it runs, ta-da, nothing happens, which means it ran successfully. Obviously. Hopefully. We'll see. Still running. Come on. It might take some time. This is a pretty large model. Error! Listen to all those errors. That's wonderful to hear. Aha! This was intentional. So, we have missing data. Amos will not let you use modification indices if you have missing data. So I'm going to hit OK. Also, it won't run if you have missing data unless you estimate means and intercepts. So let's go do that for now. That's a temporary fix. You're going to go to the colored abacus, go to Estimation tab, and click on Estimate Means and Intercepts. How on earth would you have known that? If you read the error, it tells you. There we go. And then hit X again. There's no OK. Just hit X. And let's try running it again with the not colored abacus. More errors. Yes. It's because you can't calculate modification indices when you're estimating means and intercepts. How would you have known that? Well, it tells you right there in the error. The errors are actually very helpful. I am impressed with Amos's error messages. Yours aren't doing that, so let me uncheck my means in this. Let me go to Output tab, uncheck modification indices, and see if I get another error. I'm going to run it again. Please work, please work, please work. It ran! Okay, whose didn't run? Okay.
So what did you do in the next one?
Go to the Output tab and then uncheck modification indices. One variable unnamed. You have a variable over here. You don't know what that is. Run it. The little X thing. There we go. Let's see what's your error. An error occurred because you don't have the right data set. Okay? You're going to go to File, Data Files, and find the data. It's not linked. Right, so you're missing data. Okay. And go to Files, Data Files, and then you'll find that data set. So it's not there. It thinks it's there, but it's not. Now, so hit File name, and you got to go find that data set. So it's right there. So if you ran it and said, "Hey, I can't find the data," go relink the data. Mine had it linked in there from my model, but it's trying to reference my computer when it's looking for the data. That won't work. So you got to go relink the data set. Who's still having trouble with that?
We have to find your data.
Oh.
Yeah. So okay. And go File, Data Files, and then go find the data. And then
Which is
there.
and
now, okay. Once you do have that linked, you can run it. It'll think about it. And once it runs, nothing will happen. Which means something happened.
I'm sure.
Did you want to check? Okay, now close it.
And then go to File, Data Files. There. And then go to Okay, anyone else? That's so cool. That's amazing. That's so cool. I'm gonna try that. Whoa. That was way cool. Hey, check this out. I learned something new. Don't do this. Don't do this at home, folks. If you hit tables, wait for it, and then go back. Come on, come on. Woo! That's awesome. Don't do that. Oh, I don't have an edit undo. Thanks a lot. Let's see. Oh, poop. Okay. I'll just go back to this. That's okay. No, don't save. There we go. All right. Let me go recheck those options. Uncheck modification indices. Recheck estimate means intercepts. There we go. Save. If you did it, I told you not to. If you did it, I'm sorry. Okay, I'm going to run it again. Okay, it's going to run. Eventually, there we go. Almost. Come on. There we go. It ran. Nothing happens after it runs. So, what you can do is hit the up arrow. And that will push all the values out onto the model. Problem is, these are unstandardized estimates. We don't want to look at unstandardized typically. We'd like to look at standardized. So right here, there's an option for standardized versus unstandardized, just on the left there. Click on that. And now it's too small to see anything, so let me zoom in. Okay. So what do we see? We see decision quality has these loadings, 0.7, 0.8, 0.8, really good loadings, right? They're averaging out above 0.7, very good. They're also relatively equal. There's not a 0.4 and 0.9, right? They're all in the same sort of range. Atypical use, 0.8 all the way down, that's fabulous. Playfulness, same issue, except the very top one, that's 0.64, but it's not a weird outlier, right? We have a 0.7, a 0.76, 0.64. I mean, it's not too far out of the range, and we're going to average out above 0.7. So these are pretty good. Let me go see the other ones. And so we're just eyeballing it right now. There are actual statistical ways to figure this out, but that one looks really good. Usefulness looks good. We talked about enjoy and playful, and atypical use and decision quality. Info acquisition looks good. It's one of our lower ones. We have 0.6 there, but all the rest are 0.7s. So we're going to average out above 0.7. And then comp use is all 0.7s. So we're pretty good, actually. This is really good CFA. What happens if you don't get a good CFA? What if this was like a 0.5 and a 0.4? Well, it's not going to be if you figured out your EFA, for the most part. You're going to have a good CFA if you have a good EFA. If you can't figure out your CFA, go back to your EFA. If you're only having trouble with these two, or let's say you have a super high correlation, look at this, 0.71. That's a very high correlation. That's square that, that's almost 50% between info acquisition and decision quality. If we can't achieve discriminants between those two, we need to go back to the EFA and just run an EFA with those two and figure it out, then come back to the CFA again. The EFA is really, really good at teasing out issues in your latent constructs. Okay, so those are the loadings. These on the diagonal here, these are the covariances, well, correlations now that they're standardized. These are the correlations. Square them, and roughly you get the percent of shared variance between the two variables. You can also click on your output. It's, I think, view text output, F10, or you can click on this little view text thing here. So view text output. I'm going to maximize it. If yours didn't show up when you clicked on that, it's hiding. It does that sometimes. It's real bashful, that window. Sometimes it hides behind the other window. So just look down at the bottom of your screen and try to find it. In the output, you have all sorts of stuff. First thing, we have success. This minimization was achieved. That's a success sign. You need to achieve minimization. You have your chi-square and your degrees of freedom. We've seen these before in the maximum likelihood EFA we ran. And we want, again, to divide this chi-square by the degrees of freedom in order to see a good model fit. If you divide this into that, you get roughly 2, so we're pretty good. We want it, again, between 1 and 5, ideally between 1 and 3. This p-value, you remember the p-value from the goodness of fit table in the EFA? We want this p-value to be not significant. That weird one where we want it above 0.05. I've almost never seen a p-value above 0.05 here if you have a substantial number of variables or a substantial number of rows in your data set. So I wouldn't worry too much about that. Most people won't, except the extreme purists. Reason though, I guess I should talk about, we'll talk about model fit in a bit, but the p-value there is deflated by sample size and model complexity, because those two things inflate the chi-square, which is inversely related to this p-value. Okay, but let's talk about a few things we need to talk about. We need to talk about reliability, validity to start with. Then we'll go to model fit, yeah, and then invariance, that's in CFA.
We'll get off on a tangent, but normally when you compute the chi-square, the degrees of freedom has already been calculated into it.
Right, the C-man, this one isn't. Yeah. But there's a place where it does it for us, right? It does the quotient for us. I'll show you that when we talk about model fit, but just for a sec, it's in the model fit X section, and it's right there, C-min over DF. That's the chi-square divided by the degrees of freedom. It does it for you. So we want to talk about conversion discriminant validity and reliability first. The way you do that, the easy way, is you go to the Dropbox folder, you go to the root folder and go find the stats tools package, not the old one, but the current one, the stats tools package. The old way to do this was in Excel. You'd write a bunch of formulas and then you'd have to do a bunch of stuff by hand and hope you didn't make a mistake. I thought that was stupid, so I wrote a plugin for it. So open up Excel. Hopefully that works for you. Make sure you enable macros. If it says at the top macros are disabled, make sure you enable macros. And it should look something like this, I hope. And what you'll do is in Amos, in your output, go to the estimates section, the scalars section. And you'll see there are a bunch of tables here. We want the correlations table. So these are just the values we saw on the model, those correlations. We're going to left click somewhere out here in space and then right click and copy. Because we're going to paste this into Excel. We're going to paste it in A1. Just like the button says, paste the correlations table in A1 and standardized regression weights table in F1, then click me. So standardized regression weights table is up here. Just going to left click out in space, right click and copy, and paste. And then there are several caveats that I'm not violating, but if you run this later this week or when you're doing your analysis and it breaks on you, make sure you check out these caveats and then email me. It has never not worked when those caveats are met. Anyway, click me. And what this will do is it'll produce what you need. It runs through all the tables and the values and makes all the calculations for you and then organizes it into a correlation matrix, which is what you need anyway, with the square root of the AVE on the diagonal, the composite reliability score, the AVE, which you need to establish conversion validity, this for reliability, and then the maximum shared variance, and you don't really need this column, the average shared variance, you can delete that if you want. But let's talk about each of these. Composite reliability. This is like a Cronbach's alpha, just it takes into account error a little bit better than the Cronbach's alpha. You want these values above 0.7. That says that you have a reliable construct with those measures. The AVE is the average variance extracted. You want that value above 0.5. This says essentially that more of the variance in your items are explained by each other within the vector than by other items outside the vector. So you want that to be 0.5. This is also sort of where we get that 0.7 average loading. If you square the 0.7, that's the 0.5 you're going to come up with. Yeah.
Well, you guys repeat this, like, how did you get?
Oh yeah, we'll do it again.
I got that.
I will. We'll do it again. Let me wrap through this, and then we'll do one more time. So that's 80. That's to establish convergent validity. Maximum shared variance. This is which other factor did it share the most variance with, and how much was that? So it's looking at the correlations and squaring them. So the highest one here is info acquisition and decision quality, and it turns out that they share the most variance with each other. If you go look at decision quality and info acquisition, it's 0.707. Square that, you get 0.5 roughly, 0.5 actually exactly, and that's the maximum shared variance. You would like this just less than the AE. Again, this says that there's no factor other than myself that explains more of myself, right? I can explain my own factor better than another factor can. Don't worry about the average shared variance. That's just the square of the average of the covariances, correlation, excuse me, with every factor. Again, you don't have to worry about that column. It's the average shared squared variance. Okay. And then this is the correlation matrix. So the correlations table we pasted in earlier is just rearranging it into a matrix. And then the square root of the ABE is on the diagonal. In order to establish discriminant validity, we've talked about convergent validity with this one. We're talking about reliability with this one. We talked a little bit about discriminant with this one. But to establish for sure discriminant validity, you need this number on the diagonal to be greater than any other correlation relevant to it. So for this 0.779, it's got to be greater than these guys here, below it, and these guys here to the left of it. Yes?
This spreadsheet, is it done on its own to analyze output, or does it work with other output programs?
So, quick answer, just Amos, just where you pasted it, nowhere else. I'm a terrible programmer, and I'm a really impatient statistician student. So I saw the old way of doing this, and so during lunch, I coded this up when I was taking this class years ago, and this was to save me time, and I knew how to use it, and then somebody saw it and said, hey, can I use that? And so I shared it, but really I made these for me. So they're really not robust. They're not really fine code. So you got to put things exactly where I say to put them, or else it'll break. Okay. Let's do it again for those who need to see that again real quick. You can also click reset and it'll reset for you. I have the, also if I zoom out, I think I have here formulas here if you need them for your papers. Okay, so to get that again, do we need to run from let me close this, go back to Amos. So if you run it, it'll produce some output. You go click on that output by going to View, Text Output. Or there's a little button here next to Save that you can click. And then you go to the Estimates, Scalars. You expand those by clicking the pluses next to them. And you want the correlations, so click on that. And then don't click on the value in here, although that is helpful for some of the things I'll show you in a sec. Click out here to the right of it, and then right-click it, copy.
Before you do that,
Yes.
if you want to look at your model fit and swim up with DF and all that stuff.
Back in the old day, yes.
Not
But now that this takes like 10 seconds, I always run this real quick just to make sure I'm in a good place.
But then what if your model fit is not good?
So if your model changes, you'll need to run this again. Yes. So we're going to go check.
Wait until your model is good.
So there's an order of operations, what we're getting at. The correct order of operations is quickly make sure you have a decent model, which is why I do this. Do this, check model fit, C-min over DF. You're good, you're not perfect, you're not precise. We haven't set every threshold, but we have a good enough model. Now let's go to the correct order of operations, which will be invariance checking first, actually. Yeah. Okay, back to order here. Yeah, you copy that, stick the correlations table over in A1, like the button says, and then go back and get the standardized regression weights. Copy that table and stick it over into F1, and then run the button. and then it should produce things. If you have issues, I should show a bad model real quick. Let me show a bad model. In fact, I can just change the values. I should have done that. Oh well, I'll just paste it back in. Here we go. So there's beauty to doing this with a perfect model. It's nice and easy, but you don't learn as much. Let me do it with a bad model here. Don't follow along for a sec. Okay, and I'm going to change some of these values. Let's see. Let's make that a 0.888, and let's make this a 0.022, and that might break it. Great, it broke it. Okay, so if it's not good, the tool will actually tell you it's not good. No wahoo for you. And it'll highlight in red where the problems are, and it'll tell you exactly what the problem is. For example, we have a discriminant validity issue. The square root of the ADE for useful is less than one of the absolute values of the correlations with another factor. So we go find useful, there it is, find the square root of the ADE in red right there, and it says that's less than this, 0.888. There's your problem. So you now need to go and find out why useful is so similar to enjoyment. How would we do that? We go do an EFA with just useful and enjoyment. Find out what's cross-loading and try to fix it. And then we put it back into the CFA. This used to take hours. Whoa. Okay. Anyway, and then, so that's what you do for discriminant validity. If you're having an issue with convergent validity, which we aren't in this case, but let's say this was a 0.6. Well, that's no good on a CR. And so we go to those items and see which item was the lowest loading item, and then we lop it off if we could afford that. If we couldn't afford that, then you're in trouble. What if you have a, this is balancing. Balancing. You guys ever quick stand there in Florida? No. Okay. I'm not crazy, right? It is bouncing. Okay. Let's say this is a 0.4, but this is a 0.8. If your CR is fine, your ABE is fine. There's a citation for that. If you want it, just let me know. But they say essentially that ABE is too strict of a measure for convergent validity sometimes, and CR is sufficient enough to establish convergent validity. Just let me know if you need that citation. Hopefully you'll never be in that position, but there is a citation for it. Okay. So we talked about reliability, convergent, discriminant validity. Any questions on this? What it means? Anything like that?
You could mention the rule of thumb in terms of CR should be bigger than
Yep.
ABE and CR.
Yeah, CR should be greater than 0.7, ABE should be greater than 0.5, MSV should be less than your ABE. ASV you can ignore because it's redundant with MSV. And then square root of the ABE on the diagonal has to be greater than any correlation with another factor to the left or below. Yeah, it's probably on a PowerPoint. Let's go see. We've ignored our PowerPoints so far. Hey, yeah, here it is, right here. Square root of the ABE should be greater than the correlation with any other construct. Cool. ABE should be greater than 5. Here it is. Yeah, it's all here in the slides. Excellent. And there's the CR, should be greater than 0.7. Yeah, it's all there. Excellent. And it's on the video. Not that you want to go back and rewatch the video, just saying it's there. Okay. That's our validities. Now we need to go assess model fit. Actually, not in that order, but conceptually it's easier to handle in this order. So we can do it in that order. It is 3 o'clock. When was our intended break? 3:20. Okay, we have 20 minutes. That's enough time for model fit. Some slides will be useful at this point. Okay, we talked about these. Goodness of fit. Goodness of fit applies to both measurement models and structural models. But we're going to talk about it in the context of both, actually. So in a measurement model, model fit assesses to what extent the constraints we are placing, because this is a constrained model. We said these items belong with this factor, these items belong with this factor. To what extent does this model accurately capture the natural covariances between the items? Does it account for the majority of the variance? If it does, then our model, our proposed model, fits the observed model or the data. That's the observed model in this case. So, model fit's all about whether you're accounting for all of the major relationships in your in the data. Yeah, that's what it's about. In a structural model, it's a little different. In a structural model, I think I have some pictures here. It's asking, are you accounting for the relationships between the constructs? Sorry, this is kind of small. So in this model, we're not accounting for everything. In this model, we're not accounting for everything. Notice, I'm going to have to read this out here, it's kind of small. The R square on sales ability here is 0. We're not explaining any of the variance in here. Over here, we have a regression line from confidence to sales ability, and we're now explaining 30% of the variance. Well, that changes things drastically. What if we don't account for this line and we publish this model as the model for monthly sales and explaining sales ability? It's invalid, completely invalid. First of all, because we're not explaining anything, but also because we're not accounting for some major relationship in the model. And so when we assess model fit, Amos will say, whoa, that's not right, you're missing stuff. That doesn't have good fit. And when we test this one, it'll probably say, oh, much better fit. You're accounting for this major relationship, 0.55 relationship, that you weren't accounting for before. And notice it also changes other things. So sales ability used to affect monthly sales by 0.56. And this new one is 0.47. It changes. 0.54 here for this relationship used to be 0.64. So it dampened those relationships. So these are artificially inflated because you're not accounting for some major relationship. So you cannot have confidence in a model that doesn't have good model fit, because you're not accounting for some major influential relationship in the data. So, quiz. Ceteris paribus. Which model has better fit? Knowing nothing else about this data or these models, which one will have better fit? Since you know the definition of model fit. Model B. Why?
That relationship which is missing here is a big one.
Yeah, there's one missing here. There's one missing here. So why would model B have better fit than model A?
That's 0.4.
Yeah, this is a stronger relationship. So over here we're missing a very major relationship. Over here we're missing a moderate relationship. This one will have better fit. Neither will have good fit, but this one will have better fit. On parsimony, everyone here has heard of parsimony. You want to explain the most you can with as little as possible, right? Which model will have better fit? That's a trick question. Which model will have better fit, regardless? Model A will have better fit. Why? Because we're accounting for more of the relationships in the data than in Model B. Model B is missing a lot of stuff. Model A accounts for all that stuff. Therefore, the amount of variance not explained by Model A is less than the amount of variance not explained by Model B. Therefore, Model A will have greater model fit. I feel like you ever watch Princess Bride? They're having that little argument over the wine, who's going to die, arguing with the Sicilian. Anyway, sorry. Therefore, but Model B is far more parsimonious. If we can achieve adequate model fit with Model B, then we don't care about Model A, because we're achieving the same amount of explanation with Model B, with less. We want to do as much as we can with as little as we can, typically, all else being equal. Okay. This will give us, this is good. Okay. That won't make sense. We'll come back to that, and then we'll come back to that. So let's go into Amos. Oops, CFA. Let's go into Amos. Go to your output, and there's a model fit section right here. And there's a ton of stuff in there. And every journal has a different preference for which measures you report. So I'm going to give you the ones I tend to report, the ones I like best, the ones my journals typically ask for. Your journals, again, probably be different. If you want to know what they all mean, go look at the Hare book. Also, I think it's Fornell and Larker, 1980 something, 2 or 3. They talk about all these. C-min over DF. That's just the chi-squared divided by the degrees of freedom. We want that between 1 and 5, ideally between 1 and 3. So that's good. The p-value there, again, that's the p-value we talked about before for the chi-square. We want it to be not significant because it's an indication of poor fit. So we want it to be not significant. The CFI is the one I typically report with the C-min over DF. We want this number right here in the default model, not the saturated or the independence. In the default model, which is the model we're testing, you want it to be above 0.95 typically, but according to the Hare book, you can actually, depending on sample size and number of variables, for ours it's a fairly complex model with a lot of sample, we can get away with 0.9 just fine. There are even some cases, I think, where it goes down to 0.85, I can't remember, but typically above 0.95 is what you're looking for unless you have a really complex model or a lot of data. PCFI, that's a parsimony adjusted, but we can get at parsimony adjusted through the RMSEA, which is my next preferred measure right here. And all of this is in the slides and on the wiki and in the videos. In the default model, we want the RMSEA to be, depending on which article you look at, there are literally dozens of these. 0.4 is the strictest. You want to be less than 0.4. That's a very strict requirement. Some say 0.5, some say 0.6, some say 0.8, and one of them, I believe, says 0.1. No, sorry, 0.05, 0.06, 0.08, and 0.1. So what are you looking for? I typically look for less than 0.06, because that's somewhere in the middle. Everybody's happy, except the purists. But really what you're looking for is a p close that is not significant. So above 0.05. In this case, we're good, but we're real darn close. But we're probably good. Again, we have a very complicated model with a lot of data, so we can be a little bit relaxed here. But we're already above the threshold, so we're okay. There are a bunch of other measures, the AIC, BIC, some of you will be familiar with those. The NFI, a lot of people require that. All of those, if you want, have definitions. If you click on anything in Amos output, it's pretty cool. There's some things that are awesome about Amos, some things that are really not awesome. But if I click on CFI, it says this is the comparative fit index from Bentler, 1990. Here are some other citations for you. Here's how it's calculated. Here's what it means. And then you can even click on the value itself and say, this is a terrible one, but sometimes it'll say, yes, this is good, or this meets the threshold. But again, you can click on any of these. If you don't know what they are, just click on them and it'll give you a definition and citations. Very cool. Let's pretend for a moment that we didn't have good fit. Let's say we wanted our CFI to be greater than 0.95 and we wanted our P close to be above 0.1. What could we do? There are a few things. The reasons you won't have good fit, again, is for high sample size, high complexity, a lot of variables. But if there's nothing you can do about that, well, then you can also look at normality issues, which you should have resolved prior to the EFA. But if you have normality issues, those will hurt your model fit. Validity issues, so if you don't have convergent and discriminant validity, those will hurt your model fit as well. We have all those things, and that's why we're in a good place. But if we didn't, and if we did, and we were still in a bad place, there's one more thing you can do. Two more things you can do, really. But I'm only going to show you one because the other one's ridiculously complicated, and I never end up doing it anyway. You can do modification indices. and we'll get into those. We actually have to replace the missing data first. So maybe I'll do that during the break, and then we'll come back and look at it. But what a modification indice says essentially is, hey, there's this relationship you're not accounting for. Do you want to account for that? Because that's a big effect on model fit. You have a lot of variance you're not explaining, but if you accounted for this relationship, you would be explaining a lot more variance. And so it'll tell you what you're missing. In a CFA, we're accounting for every relationship, except, like from here to here. And so the way it deals with that is through error relationships and error. We'll talk about that. I think I'm going to take a break right now. It's only 3:10, but we'll break early, and then I'll keep that going during the break, and we'll come back in 20-ish minutes. Okay. I guess, sorry, one more thing. Do you want to see how to replace missing data in SPSS? Because that's all I'm going to be doing right now. No, all right, we're good. Oh wait, some people do. Okay, so we'll take a break and then I'll replace that data in front of you. Have it in. Right, you have to run it at the very end as well. Yeah.
Right. So that is where you have a model, and now you want to know if you're all good in terms of discriminant conversion. So did you do that in that order with the
correct order would be to do the invariance test at this point. But the invariance test is a whole new concept that I've learned about. And so that's why I sort of go in reverse. I go conversion to discriminant validity because we just did that CFA, so it makes a lot of sense.
Okay.
And then I do model.
If we do it at the end of it, let's suppose, I mean, this is a very good fit. Suppose you had a terrible.
Right, it would change.
So if you show a terrible and then purify it, and then
Yeah, we'll definitely do that.
integrate
Yeah.
conversion and discriminant validity methods, and then also say, I actually don't see a lot of them. Because they don't know what you're looking at, how you're defining this is good, this is not good.
Right.
You could say this column should be larger than this. This should be smaller. You know what I mean? You kind of step back.
Did I? Oh, no. Okay. So we'll go back through. That's a good idea. We'll go back through, do a simpler model.
They don't do that. Then they even more lost what SEM
And then X out of it.
structural
Sure.
equation.
And now you want to run. So yeah,
Okay.
finish should run.
Then
Now,
It's just as simple as, just
loading.
this will be represented that you then record it. So here's how we draw, if we did it manually. This is how we push on, and this is how we end. If you got a good model, here's the V, ABB, bodies, ABB, MSD, and now you can publish and convert it. Numbers we talk about in the application. I do not so I know, and identify it. But I could see
Sure.
logs.
That's fine.
And it's the something like that needs to stop. Stop it. But that's because
We'll go back to it. Yeah. Okay. We'll go back to it. And then we should be able to make it hopefully through all of it. If we don't finish CFA today, that's fine. Structural models won't take that long. Okay. Won't take the full day.
I think it is good. I think it is very important.
Okay, good.
If you can just see this and start it now, I think that is about that. You know,
Thank you. Thank you.
No, thank you.
no, you're, you know, if you want to be known, and then you need to have it so you know,
Yeah.
I'm not sure everything is
Cool. The next thing, we got a name errors. Error terms. And the EFA did not show up afterwards. They don't show up. It would have been there.
Yes.
So that's unselected, closed hands. And then, oh, we need to get straight on all those. Did you erase them all? Yeah, all of those need a correction. So you don't have to close it each time. Except here, you don't get here, and then you need a one on various of these. And we're not going to go back through and build a simple model like this. We're going to go immediately after this. We're going to replace missing data and then we'll get that. Because I think a lot of people, I was doing this stuff really fast.
There are other softwares that can still do this.
Yeah, so instead, so what I did instead, I square root the regular correlation. So it's the same thing. You can either square root the correlations and compare them to the AB, or you can square root the AB and compare the correlations to square root of the AB. And then you compare them to everything below or below. So, less than the yellow. Yeah, the blue must be less than the yellow. This is German blue. We're going to do this all over again because I do so much stuff with everybody all at once.
comparing these and
Yeah. There's a lot of new stuff all at once. Yeah. No. Yeah. Right. So up there. Right here. There it is. There you go. Now let's spring. It's because it's accounting for more of the major relationships. So what this will count is our relationship and medium. This will count to change the order.
Did you already eat it?
Yeah. It doesn't take me long.
처음에는 이걸 인바운드 이 데이터 파일이랑 얘네들이랑 같은 소리에서 그려야 돼요. 그냥 이거를 카피 그 폴더에 옮기시면 이건 데이터
Oh, that different. Wow, that's very different.
The measurement errors, I don't know the reason.
Typically, yeah, the Cronbach's alpha is less sensitive to measurement error, so it can go in either direction in the wrong direction, whereas the CR typically is stronger, more reliable measure of reliability. So I'd go with the CR. Typically, when we report it, though, the reviewers like to see a Cronbach's alpha because that's the old way of doing it, so they're just used to that. So you can report both. Yeah, so I'd report the CR. Typically, CRs are high.
The reason could be because maybe the device
maybe if there's a lot of error, you look at the APE. How's the APE? Because that'll be a good indicator of also the reliability. So then, so usually the APE is lower than the reliability measure of CR or Cronbach's alpha. So if you see an APE that's high, then the CR should also be high.
But what about a little bit lower than expected?
The Cronbach's alpha or the APE?
CR is lower.
If the CR is lower, then you might have some issues.
Issue could be
Issue is typically related to the amount of error. So when yeah, so let's say here's your construct, and you have an item here, an item here, an item here, an item here, here, and here. The reliability is assessing how these move together. If somebody answers 5 for this one, do they typically answer 5 for this one, 5 for that one? Or do they not move consistently? And these distances represent those movement disparities. So something like this might have a CR 0.788, whereas if I get rid of this, we now have probably a CR 0.850. Get rid of that one, 0.950. Possibly. And the way you would know is by the loading value in the pattern matrix. Yeah. So, or if you go to the Cronbach's alpha if item deleted, remember that one. You can look at that. Yeah. You're welcome.
I'm going to need this reference for the CR.
Okay, yeah, it's Malhotra and Dash. Let me pick it up. Let's see.
And with that ABE and this correlation thing, I forgot to ask, like I myself and my friends often face when ABE is less than skirt correlation, like one of the ABE is less than the skirt correlation, and what would be the solution for that?
Let's work through a problem. Right after this, I'm going to go through again with a simple problem that's problematic. A simple model that's problematic, and we'll so hopefully see an ABE that is having troubles, and we'll work through it. But the thing you're looking for is a dash, I think is. Come on. Wow, I emailed with this person a lot. Some people ask a lot of questions.
We try to
answer every single one. I think I found it. Yeah. Malhotra and Dash. Here it is. I even have a quote. Wow. It's Malhotra and Dash 2011. Oh, my heart rate dropped. Oh, no. Oh, you're welcome. I have to lay down.
Yeah.
All right, we'll get started again. Missing a few, I guess. I wonder if we should go grab them. Oh, here they come. I think that's mostly everybody. Were there many others? All right. Looks like most everybody's back. Okay, a couple things. Just as a warning, I just had a bit of an episode. My heart rate was in the 40s, so hopefully it won't happen again. But if it does, I'll need to lay down again. Luckily, it happened during a break. That was convenient. Other thing, I talked to several people during the break, and I went really fast through a ton of stuff. I'm going to go back through, and I went through a clean, beautiful model that worked just perfectly. I'm going to go through a very simple, broken model built by hand. Find out what the problems are, how to fix them, and describe what everything really means once again. I think repetition is very important on this stuff. We have time today. If we don't finish CFA today, I'm not worried. Our structural models tomorrow will not take the whole time. So this will be good. But before we do, I want to fix the missing data that we saw. So in Amos, there's issues when you have missing data, when you have values, cells that are blank in Amos or in SPSS, then when you try to run stuff in Amos, it won't run. It says error, you have to estimate means and intercepts. Then if you do that, you can't check model fit very well later. So we're going to fix this. So the way to do that is, first off, isolate the variables you're actually using. So for us, that is, let's see, let's go back to, I closed that model, didn't I? Well, I think I remember what they are. Oh, here they are. Useful, enjoy, play, decision quality. I'm just going to drag these to the top. And if you want, I can just do this and then save the file, and then you can pull it back down if you want, or you can follow along if you'd like. What we're going to do is grab those ones we're using. Here it is, enjoyment. Drag that to the top, all the way to the top. There we go. And usefulness was another one. And play, oh, there's play. Let me grab play. I hold shift and click on the row number. Drag that up to the top. So I'm just putting these all at the top so they're more easily accessible for now. And then we had decision quality and information acquisition. So not number 13 or 11. Oh, you can hold control to deselect as you click. Again, you don't have to do this. I'm going to save this data set after we replace missing data. But this is how you would do it. And then we had useful. I think we had comprehensive use as well, didn't we? So let me throw that one up there. There we go, that's at the top, and then comprehensive use is right there. There we go. Is that everything? Usefulness, enjoyment, we got playfulness, decision quality, atypical use. I'm not sure we got that one. There it is right there, atypical use. Last one. Oops. Okay, and drag that up. Again, this isn't necessary, but it makes it a lot easier to work with your data once you decide which variables you're going to be using. Okay, to replace missing values, first we have to find out which ones have missing values. To do that, you would go to Analyze, Descriptives, and Frequencies. I usually do this on the first half of the first day during a normal boot camp, but we skipped that part. So, Descriptives, Frequencies. Throw in all those variables from the top that we're actually using in our analysis. Oops, what did I click on? And then you'd go to statistics. We don't need anything, but if you were looking at data normality, you'd click on skewness and kurtosis. Everything else is fine, except make sure to display frequency tables. This checkbox down at the bottom left. And then hit OK. And what it's going to do is it's going to produce a ton of tables. But we just really want to go to the very top, and there's this one frequency table we want. And we want to see if there are any missing values. So here's the missing row. It says 0 missing, 0 missing. Let's scroll over. Ah, some non-zeros. Useful 1, 2, 3, 4, 5, 6, 7 all have missing values. Wow, a lot of these have missing values. How about that? Holy shnikes. Playful is missing several. Wow. Okay. Yeah, we could do that. Yeah, you can always stick this in Excel. Copy to Excel. Paste it in here. Whoa, it pasted as a picture. That didn't help. Because my default copy is the picture right now. Save as default. Yes, okay. Paste, there we go. And if you Control C, Control V, Control T, it transposes it. Or there's a little button here you can click on that has transpose. Anyway, but that's how you do that. And then you can just look in here to see what's missing. So what we'll do is we'll go replace those values. You go to Analyze, not Analyze, excuse me, Transform. Replace missing values. Let's transform, replace missing values. And then you can select all these ones at the top. All the ones we're using. Throw them in there. And then ooh, I wonder, I'm just playing for a sec, ignore. If I change this to median of nearby points to start with and hit all, and then send it over, oh, that's awesome. I never knew that. Okay. Okay, so there are different ways to do this. You can, oh, sorry, that's way down the bottom here. If there are different methods, you can replace using the series mean. That means just take the average of whatever's in the column and stick that in the missing cell, in the blank cell. You can take the mean of nearby points and just say, hey, take the 5 above it and the 5 below it and average those. Or you can take the linear interpolation. These are probably more accurate. I'm going to use the median of nearby points. Why the median? I'm using Likert scales. And there's a 1, 2, 3, 4, and 5 on a Likert scale. There's not a 5, but there's not a 2.7 on a Likert scale. And if you do the mean, you'll get a 2.7 or something like that. Whereas if you use the median, you'll just get the whole number. So I'm going to throw the series median, or the median of nearby points, and then say for the nearby points, give me all of them. So that's going to take the median of the entire column. So if everybody on average median responded with a 3 will go in there. Yeah, if that's the middle point in my responses. And then I throw over all the variables that need to have replacement done. not all of them did. I can't remember which ones did. I'm going to throw them all in anyway, and it'll say, well, you don't need to. Let's see, hit OK. It'll do it anyway. It'll say how many it replaced. You'll see for these first ones, it didn't replace any because there weren't any to replace, so that's fine. And what this did is it created a new set of variables. You go scroll down to the bottom here. Here they are. Atypical use 1_1, 2_1. It's kind of annoying, but that's what it did. You can rename them actually to the same thing they used to be, but then you have to go through all these check boxes and warning boxes. But there they are. We still know what they are. So those are our new ones with no missing. I'm going to save this. And now it's in Dropbox. You can download it if you need it. Yep, it is uploaded. Now the only problem is the variable names are different. All right, one moment. Here's what we need to do. All right, I'm going to go and copy all that data I just made over to the beginning and replace the values that I had. I'll explain why. Let's see. Here we go. That right here. Control Shift End. Will that work here? Yes, it did. Control C. Think about it. Control Home. Control V. Okay. So what I just did is took all those values we just created and stuck them back on their original variables, so we can use the same model in Amos. Let me save this. Actually, let me delete all the ones that's at the bottom because I don't need them anymore, and it's just making for a larger file. Yep, here we go. Delete all of you. Deleted. Okay, now I'll save. Now it's on Dropbox and very useful. Okay, it is uploading to Dropbox. Now it's on Dropbox. Refresh your window and you'll be able to download it. If you don't refresh, you might get the old file, so make sure to refresh. Okay. And then we're going to go build a problematic model and work through it. Nice and easy. Yeah.
In this case, we don't have any that much missing, but what if we have so many?
Yeah, good question. Another thing I usually cover in data screening. What if you have a ton of missing data?
Much better to use expectation maximization, because in this case, all the missing went with the same number, which is
median. And in this case, we're only missing 2 or 1. Not a big deal. Not going to have any effect. If you're missing more than 5% of that column, that's a big problem. And if you use a median, the central tendency, what it's going to do is it's going to dampen all other effects. It's going to reduce your R-squares. It's a big problem. And typically, if you're missing more than 5%, that tells you there's something going on with your survey. Either people didn't like something about it, it was too long, it was too offensive, it was asking questions they don't want to answer. And so you have some sort of a bias. Now, can you impute and replace those missing values if you have more than 5%? You can, even with an expectation model, like an interpolation model. But you're still creating artificial fluff.
No, I mean, we are still in the 5% range, but the database is really big. So, like, we have 1,000 something, so we have 200 missing.
Yes.
And
yes, that would be better to use more like a regression method or an interpolation method. Yeah. If you're missing more than 5%, then there are other issues you need to resolve. You typically don't want to replace more than 5%. There are some papers that say you can replace up to 20%. It's a lot of data. I don't recommend that. You'll probably find no significant effects. You're essentially, yeah, you're just making up data. That's another thing you're not allowed to do, by the way. No making up data. Okay, let me save this. We're going to start a brand new nasty model. If you totally get this, you're just on top of things. You're welcome to your email right now. But I'm going to work through a small problematic model for the rest of us. Okay, let's do this. I'm just going to make one up off the top of my head. So grab the candelabra. you're going to click and drag to make your first one. Don't just click, or else it might end up giving you a single pixel variable, which would be too small. So click and drag to make your first one, release, and then everyone after that, you don't have to click and drag. So click, 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 click. Let's give it 4. Let's do another one. Click, 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 click. Another 4, and another one. Click, 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 click. Okay, we have 3 4-item latent factors. We don't know what those are yet. We're just going to make this up. I'm using this little rotation thingy button. You're going to click, 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 turn them around. You may have noticed clicking and dragging an item out, an icon out to the canvas doesn't work. You have to click and then click. You don't click and drag. All right. To move these all around, we're going to use the fire truck and the balloons. The balloons say maintain symmetry. That's what that means, the balloons. We're going to move it around. If I move too fast, the whole point of this exercise is to make sure everybody's on the same page. So if I move too fast, holler. Doesn't have to be beautiful or perfect unless you're totally OCD like me. Then it does. Again, if you're not getting this, ask your neighbor or ask me. I see lots of people not getting it. Lots of people asking me. Oh, that's beautiful. Hit undo. Okay, and get the candelabra. That's because you're clicking. Yeah, so hit undo. And undo. Because you have single click, keep going undo. There you go. Get that. Yep, and then click drag. There you go. That's probably a little too big. So undo that one. Make a small one. Your special case, it's okay. Click and drag a small one. Bottle cap size. That's probably too big, but that's all right. Oh boy. I think you just like drawing. There we go. All right. She got you covered. She got you covered. All right. You can find but the inside here, I can click this one. So one thing, I think for this one, there we go. And then you can want it here. And then you can rotate it. Let me show you one more time. Amos is so not intuitive, so not user friendly. So check this out. If you click and then click, what it's going to do initially, if you haven't set a size, I've already set a size for these. They're exactly this size. If you haven't set a size, it will create a single pixel latent factor, because that makes perfect sense, right? So what you need to do for your first latent factor is not click and click. You need to click over here to get it selected, make sure it's selected. And then over here, click and drag and set the size of your first factor. Now, if you've done this several times, I highly recommend creating a new canvas that's a clean canvas, because when we go start to run things, you're going to have errors saying, hey, you have an unnamed variable. And it's really just an invisible single pixel variable that you didn't know was there. So I strongly recommend you create a new canvas if you're going to, if you have that error.
Is there a way to calculate the whole thing?
Yes.
No.
I'll show you. For those who are here, let me show you a cool little trick. Let me get rid of these. By the way, to get rid of things, you use this little X mark. It looks like an X on a pirate map, treasure map. Okay, if you want to copy and paste a whole thingy, what you would do is use this Xerox machine, obviously, and then click and drag. Kind of cool, huh? And make sure to click on the latent factor when you do that. Oh, yeah, also the balloons button. So you could, it'd be easier just to delete these actually. Yeah. And just make the initial latent factor smaller. Because the initial latent factor is the foundation. Yeah. Nice and small. Okay. Anyone else? I'm so glad we're going back and redoing this. Looks like the right thing. Yeah, sure.
My name is.
Yeah, nothing happens, that's right. So the next thing is to click on the catalog. And then don't drag it. So there it is. Mark here. And then you can drag. There you go.
There's
So yeah. Yeah, file, take files. Nothing happens, right? Yeah, it should say loaded successfully or something like that. Wouldn't that be nice? What we have to do is click on that. Oh. Yeah, how you doing? If you want to move it, fire truck and up balloons. Take like a late. Good-ish. We have. Okay. All right. Okay. Next thing you want to do is covary these latent factors. You can either do it manually with this double-headed arrow. By the way, it only draws clockwise. Or you can do it with the plugin. The way to do it with the plugin is to select with this finger pointer these 1, 2, 3 latent factors, and then go to plugins, draw covariances. And that'll do it for you. That's really useful when you have more than 3 latent factors. Again, that was, you select with the finger pointer the 3 latent factors you want to covary, and then go to plugins, draw covariances. Okay. Then to deselect all of that, hit the closed hand, the fist. That deselects everything. Okay. The next thing you want to do is you want to pull in the variables of interest. But we don't have any variables yet, so we're going to go to File, Data Files. Go grab the data. I haven't done that yet, so I'm going to grab the data. And if it's grabbed correctly, the N will show up, minus 381 over 381. That means I'm using the full data set for this group number 1. We'll use different groups later. And hit OK. So now we have data. It doesn't show up anywhere. If you click on this little white stacky thing, this white stack, there's a blue stack and a white stack. You want the white stack? It's variables in the data set. I think you can also go to view variables in the data set right here. And then we're going to pull in some variables. Let's make this a really problematic model. So how do we do that? Let's throw in design expectations fit. That's awful. Throw that one in. And that one. Just all 4 of these. And let's use skill acquisition, also awful. And either efficacy or usefulness will probably have discriminant validity issues with these guys. So let's try efficacy. 1, 2, 3, 4. And yours will probably look pretty messy like this. So I used efficacy in the top, design expectations fit in the middle, and skill acquisition in the bottom. And it looks awful. The next thing to do, again, if I'm moving too fast, stop me, because we're trying to do this together. That's why I take so many drinks. Pauses. Okay. You want to go to View, Interface Properties. What we're doing here is we're going to get rid of the long label. We're going to just see the variable name. View Interface Properties. In the Miscellaneous tab, you're going to uncheck Display Variable Labels. Oh, there's snap spacing. That's cool. I've never tried that. Huh. Should try that later. Cool. I'm learning new stuff with you guys. This is great. Hit apply, and those will show up. Hit close. The next step would be to go to plugins and resize observed variables. That's just going to make them all fit properly. There we go. Plugins resize. The next thing is to name your latent factors. So I'm going to double click this big ellipse and call it efficacy. The next one, and you don't have to close this window in between, you can just leave it open. The next one, I'm going to call design. Just design, I think, is a good way to do it. And the third one, I'm going to call skill acquisition. There can be no spaces in your variable names, so make sure there are no spaces. Also, no plus or minus signs or other things. I don't know if there is a length maximum, but I don't recommend anything too long. Yeah. Okay, and then you close that. The last thing to do is plugins, name unobserved variables. That will name all of our error terms. I'm going to do that. Plugins, name unobserved variables, and then make sure everyone's up to speed. Raise your hand if you need something. Don't be ashamed. You won't be the only one.
So that's why I'm and then and the same issue. Real precisely. Cool. All right. Well.
If I wanted to.
I strongly recommend either saving or closing the reopening this file. Or if you want, I can save this. I'm going to save this model, and you can pull it down under it. You can pull it down off of Dropbox if you need. I know that doesn't help you resolve the issues you're currently having, but it will provide CFA problematic. Okay, it's called CFA problematic. There we go. And then, unfortunately, we've saved everything. There we go. Anyone else? Okay. Okay. We good? Yes. That's bizarre. I'll show you. If your model's not super pretty like this one, there's a way to sort of fix it. Depends. I mean, it'll fix some of it. It'll make it more symmetric. If you select all with the open hand, and then click the magic wand, and then click on anything, it'll make everything more symmetric. You can click on it a couple times just if you want to be safe. You're welcome. Okay. And then deselect everything. Okay, save. All right, so we've built a model from scratch. This is going to hopefully be a terrible model. I really hope so. I'm just guessing because I've never tried this specific model before. First thing we need to do, go to Analysis Properties. After we've saved it, make sure you save yours. Does anyone have floating variables named like F1 and F2? Good. Okay, it can happen. So make sure to save this. And then we'll go to the colored abacus, which is Analysis Properties. I still hear typing, so I'll wait. Okay, so you go to Analysis Properties, which is the colored abacus. And we go to the Output tab. And you want to check Standardized Estimates and Modification Indices. Standardized Estimates just provides us with the standardized loadings for all those lines, and it gives us the correlation values instead of just the covariances. And Modification Indices provides us a way to improve our model fit if we can't achieve it naturally. We haven't talked about them yet, but we'll get to it. Okay, and close. And run with the not colored abacus. Error! Oh, bother. We're using variables I didn't replace the values for. All right. That's what happens. Okay. Then let's use variables we did replace the values for. Or we can go back and replace the values. That'd be lame. Let's use variables we replaced the values for. So here's what we're going to do. Click on that white stacky thing again. And let's just use the variables we had in our model before, but let's just use some problematic ones. like design. Oh, haha, I know what to do. No, we didn't do those. Urgh. We'll be close. Okay, let's use. Dang it, I didn't think through that. So we're going to artificially create a problem. That's what we're going to do. You're going to have, instead of design expectations fit, you're going to throw in comp use. So the reason it didn't work is because I have missing data in these variables. We didn't replace with a median for those variables because we weren't interested in them. So, and then instead of skill acquisition, let's throw in decision quality, or excuse me, information acquisition. 1, 2, 3, and 4. Hopefully that'll give us a problem. If not, I'll have to fix it all. Yikes. Okay. So now we have comp use. Sorry, I didn't think through that. Comp use and info act. Okay. Just because I'm silly, I'm going to move these out. Oh, nope. Move these out. Okay. You don't have to do this. I'm just have more room. Okay. Let's run this. It should run. There we go. It did run. Hit the up arrow. And unfortunately, it's perfect. Okay. All right. I'm going to go replace the missing data. Ah, yeah. Sorry about that. That's what happens when you do things on the fly, I guess. Do not save changes. Correct. There it is. This is the old model. I'm going to go fix that data, upload it to Amos, or to Dropbox. Okay, we were looking at design expectations fit and let's see, transform. Don't worry about doing this. I'll do this. Replace missing. Control A. Get rid of all those. Jump down. We were looking at design expectations fit, efficacy, and ease of use. Not ease of use, skill acquisition. Okay, medians all okay. There we go. Go over to here. Don't worry about what I'm doing. I'm just going to fix these real quick. Okay, and then fix these. I'll save this. Okay, it'll upload to Dropbox. You'll have to relink the data. There we go, it's uploaded to Dropbox. Relink the data. Sorry about that. Okay, so all you need to do is go grab that data again and relink it in Amos. Sorry about that. Wasn't anticipating doing a model with these variables. Hopefully it'll break after all that. Breaking the way we want it to. I'm going to get trouble to that. There you go. Any other questions? Awesome. Oh, yeah, so we want to upload the new data. Yeah.
times as well, which we had efficacy for. Very long, very long. Efficacy. Yeah.
Oh. Did I delete efficacy? Oh, I'm having a bad one. Let's see. Did we delete efficacy? I managed to delete efficacy. Brilliant. Okay. Unfortunately, the data I just gave you won't work. So, poop. Here's what we'll do. Instead of efficacy, use usefulness. I'm sorry. Wow. Okay, use usefulness 1, 2, 3, and 4 here. There we go. And rename this usefulness.
All right. Well, we can work afterwards if you want, or during lunch.
Okay. Okay. Are we at this point? Sorry about the hiccups. Run this. Please be awful. Nothing? Nothing's worse than awful. Oh, okay. If nothing showed up, go to your analysis properties. For some reason, these unchecked for me. Hopefully you didn't have that problem. Save. Run. There we go. Okay. Now let's look at these. Really? Oh. Okay. They're all very nice. Oh, I'm glad you're laughing. Good, the model fit's awful? That's awful. It could be improved. 62 here, that's not that great. Let's see what we have. It's going to be mostly fine, unfortunately. I have great data. Here's the problem. I pre-tested this data so many times that it's gorgeous. It's hard to break it. So lesson learned, pre-test your data a lot. So you can feel awkward up in front of a big group of people when demonstrating it for its not awkwardness. Okay, so let's check model fit because we hear there's a place there we can improve. So clicking on your output view, text output. For me, mine's hiding back here. So check at the bottom of your screen if yours is hiding. We go to model fit. And oh, you're right, model fit isn't very beautiful. Look, our CMIN over DF is almost 5. We'd rather have it under 3. 1 to 3 is nice. Our CFI is less than 0.95. We have a fairly simple model, so we should be able to reach 0.95. It's at 0.933 right now. Our RMSEA is 0.102. That's above any published threshold. Our P-close is significant, less than 0.05. That is not in the area we want it. We want it to be above 0.05. We have a problem with model fit. So we know that we can do a few different things. First off, we need to check the distributions. We should have already done that. So we're going to assume we have normal distributions. Probably a terrible assumption, but let's assume that for now. The next thing would be to look at convergent discriminant validity. Do we achieve that? I think we do. Let's go find out. Go to estimates, scalars, and then correlations. You're going to grab this table, left click out on the right side of it, and then copy with a right click, copy. Go to the Excel stats tools package. I'm going to reset this one and paste in A1 and do the same for the standardized regression weights, but in F1. So standardized regression weights, left click, right click, copy, F1. Let you get to that point. Okay, and then click the button. No validity concerns. So this isn't the problem with our model fit. This is not what's causing the issue. Something else. Let's find out what it is. The only other thing we can think of is modification indices. So click over here on modification indices. And here are all the suggested changes to our model. So you have a lot of issues. You have a lot of really related items that you're not accounting for that relationship very well. What we're looking for is the highest number in here. If we have a 78 up at the very top, we have a 50 right here. So E11 and E12. It says these two, their variance, their movement is very in sync. They move together. These are errors. What is this really telling us? It's telling us that the items they belong to move together very well. The problem is we can't very well draw a line between those two variables. Let me show you which ones they are. E11 and E12. If we go back to our model, E11 and E12 are right here. Skill acquisition 1 and 2. These are strongly correlated, but we can't draw a line from here to here. We can't draw a covariance between them because that's actually an illegal action in Amos. You can't draw a covariance between endogenous variables. So the next best thing we can do is draw a covariance between their errors. Well, now what does this mean? Or covarying errors? That seems kind of squirrely. What this means is we want to account for their systematic relationship. We expect skill acquisition 1 and 2 to be related to each other. And in fact, we have even more suspicion that they're related to each other because they're right next to each other in the survey. If you didn't randomize the delivery of your survey questions, those happened right next to each other for every single person. So they probably read the first one and said, oh, yes. And then they read the next one, they're like, oh, this is the same thing from the last one. Yes. And so they probably just answered them the exact same way. So what we're going to do is either go look at those two questions and see if they truly are identical questions, because if they are, we're going to get rid of one of them. It doesn't change a thing. Or if they're not identical, covary their errors to account for their position in the survey. So let's go look at what they said. If I click here on my white stack here and go look at skill acquisition 1 and 2 down at the very bottom. Oh, it deleted it. I don't have those anymore. I'm just having a great one today. I have them somewhere else. Let me show you. Okay. They're over here in my other backup. Okay, go down to skill acquisition. Where are you, skill acquisition? There it is. Okay, up 1. Okay, number 1 and 2 said, when I use Excel, I learn new things. When I use Excel, I discover new things. Those are almost the same thing. I changed one word. So we can either, again, get rid of one of them or just covary their errors. Which is better? If you ask me, I'd rather get rid of one. And if you ask purists, they'd rather get rid of one. If you ask certain others, they'd rather keep as much as they can, and so covary the errors.
But if you have only 3 indicators, it makes sense to keep.
Yeah, okay, yeah. If there were only 3 left, right now we have 4. If we only had 3, I wouldn't want to get rid of one, because that leaves us with 2, which is a very unstable model. So I have 4, I'd like to get rid of it, but just to show you the other method, you could covary. You hit the down arrow on your model, that unfreezes everything, and then click the covariance arrow, this double-headed arrow, and you're just going to draw from E11 to E12. Now you're going to remember our RMSEA was 0.101, our P-close was 0.000, our CFI was 0.933, right? Our C-min over DF was 4.9 something. So we were in trouble. Let's see what it is now. Let's run it again. Go look at the output. Go look at model fit. Look at our C-min over DF. 2.6. That really fixed some stuff. Look at the CFI, 0.97. That's above the 0.95 threshold. That's great. RMSEA, come on. 0.066, that's acceptable under some published thresholds. The P close, still not in the range we want. It's less than 0.05. We want it greater than 0.05, so there's more we can do. Let's go look at the modification indices. Go find the biggest number here. What do we have? Yeah, E3, E4, that's 47. That's really the big one. Now, would I have just taken all the big ones in the first table and done them all at the same time? The answer is no. They likely won't change a lot, but they might change, and so I like to do them one at a time. Unless I have a model that's just ginormous, and then I do a couple at a time. Okay, so E3 and E4. Oops. Again, I could go look at their wording and find out why. I'm guessing here it is usefulness 1 and 2, right? Yeah, usefulness 1 and 2. Here they are right here. Using Excel in my work enables me to accomplish my tasks more quickly. Using Excel improves my work performance. Similar, not identical, but same idea. But that's the whole idea between reflective items, right? They should be mostly interchangeable. So I'd like to keep them both. We'll just covary that error. One reason you don't want to covary errors is you're reducing your degrees of freedom. Every time you add another line to your model, you reduce your number of degrees of freedom by 1. And degrees of freedom is the denominator in a lot of model fit measures. And so every time you reduce that denominator, you're inflating the measure in the wrong direction. So that's one reason you wouldn't want to do it. Here we go, run it again. We had good Cmin over DF, we had good CFI. We go to the model fit, still looks great, looks fabulous, but we didn't have a good RMSEA and P close. Here we are, looks tremendous. We have RMSEA of less than 0.05, 0.04 is the lowest threshold I've seen published. That's less than 0.04, that's great. And then the P close is way over 0.05. We're in good shape. This means we have a great model. We're accounting for all of the major relationships in our model. So we're good. That's model fit to this point. Yes.
The question is about correlating the zero term. Basically, we say we cannot correlate from one construct to other one. Yeah?
Really good question. Let me show you. Okay. If I go to the modification indices and I look through these, most of them are going to be nearby each other, right? But some of them are not. Let me go to E4 and E10. That's a very large one, 10. And if I go look at E4 and E10, over here, that is useful 1 and skill acquisition 3. Why on earth would those be related? Well, let's go look. Useful 1, skill acquisition 3. Useful 1 says, using Excel in my work enables me to accomplish my tasks more quickly. Skill acquisition 3. Where are you? Did I skip it? There it is. Skill acquisition 3. When I use Excel, my skill increases. Isn't that what I just read in usefulness? Usefulness 1. Something. That's close. It's similar. So there is some relationship there. We'd expect those to be correlated, maybe not that strongly. But if you see two errors that are strongly correlated and implied by the modification indices that there should be a covariance between them, but they're from different factors, the first thing I would do is go look at the wording. If they're really similar, you're justified. You can covary those. If they're totally different, that's just weird random error that happened to be correlated. What do you do at that point? Go read what Dave Kenny said about it. Dave Kenny is a notable statistician who has written quite a bit on model respecification, what we're doing right now. If you just type into Google Dave Kenny respec, R-E-S S-E-C. You'll find his website on respecification, and he talks exactly about this issue of when and when not to covary errors. My rule is if there's a good reason they should be correlated, like looking at the wording or the placement in the survey, then I say, yeah, you can covary them. And this is what he says essentially as well. But if there's no good reason for them being covaried, it's hard to justify adding that covariance error.
Rosen would say it's not a good idea to covariate to constructs.
That's right.
Now, my question was, if we had longitudinal study and we are measuring the same construct in different time periods, are we allowed to covariate those errors?
So in a longitudinal study, if you measure the construct before and after, those should be causally linked.
We cannot correlate any error.
You wouldn't need to, because they should already have a regression line between the actual variables.
Even after causal path.
If there's still an error, I don't know, that's a good question.
The other
I'm
one
trying to think what it might do to it. What it'll do, if you covary the errors on a time 1 and time 2 variable that are already regressed on each other, what it'll do is it'll suck out some of the explained variance from that regression line, and so you'll dampen the effect observed between them.
Is it dampen or just make it more real? Because it's not
You'd be isolating, the realness, because what you're doing is you're extracting error explained, variance explained by error. So yeah, I suppose you would be making it more accurate.
And one more thing, if I have a non-recursive model that has feedback,
Feedback loop.
so is it a must to correlate those error trends between the construct?
Feedback models, typically we don't like to see those in Amos or any SEM. I don't deal with them, so I'm not sure. But there are some weird inflations that must occur when you have a feedback loop. I haven't played with them though. If it were me, I think I'd draw them separately, but then you isolate. Yeah, you're looking at things in isolation. Okay. Is it really 4:30? Oh my goodness. Okay. That is model fit on a rough model. Sorry, I don't have a terrible model for convergent discriminant validity. Again, what you do if you had a discriminant validity issue, so let's say that design expectations fit and skill acquisition had a correlation of 0.8, very high, and they couldn't achieve discriminant validity. What you do is run an EFA for just these two. So grab these items and these items, run an EFA, try to fit them into two factors by looking at the cross loadings. We did that with skill acquisition, or no, info acquisition and decision quality initially. And then once you refine that EFA by maybe dropping an item that's cross-loading, stick them back into the CFA. That's when you do with discriminant validity issues. If you have a convergent validity issue, what you gotta do is look at the lowest loading item and maybe lock that off. Because what convergent validity is estimated by it's the loadings, essentially the squared loadings averaged with a little other stuff in there. And if those don't square and average to about 0.5, you're in trouble. So that's what you do. So let's say skill acquisition 4 was loading at 0.0 or 0.33. All these were 0.7s. You can drop that one off. So sorry I don't have terrible data. Next time I'll come with terrible data. I have lots of examples of terrible data because I've advised a lot of students. So we have a lot of bad data. I just didn't bring it with me. Okay. Any questions about that? We've only covered model fit and convergent discriminant validity for CFA. Okay. Trying to think of what we should cover in 30 minutes here. We have left invariance tests, which we could probably cover, and method bias, which we couldn't cover. Let's do invariance tests. Okay, so when you are running a measurement model, and you know in your causal model, later your structural model, that you're going to want to see the difference between 2 different groups or 3 different groups. Let's take gender, for example. I want to see how autonomy affects performance differently for males than for females. If I'm going to do that in my structural model, I have got to do it in my measurement model as well. I have to see if the loadings are roughly the same for males versus females, or for whatever categories I'm using later on in my causal model. Because if they're not the same, let's say skill acquisition 1 loads really great with skill acquisition for males, but for females, it actually loads up here. Well, if I don't know that, and I go ahead and start drawing causal arrows between latent factors, I'm not measuring the same constructs for males and for females. I'm measuring 2 different constructs. And so that's a problem, because that relationship that we will then observe for men and for women will mean something totally different for men and for women. It's not this predicts this, it's this thing for females and this thing for females versus this thing for males and this thing for males, which are not the same thing. So we have to assess whether the measurement is the same. And to do that, there are multiple ways. I'm going to show you the easy way, because I prefer the easy way. Just makes sense. What you do is you go to your analysis properties. That's the colored abacus. I think you're getting familiar with the interface now. And you need to check this box for critical ratios for differences. What this is going to do is it's going to create a Z statistic that represents the amplitude of difference between regression weights for one group and regression weights for another group. So it'll create a Z statistic for every single path and say, here's the difference between male and female, or whatever groups you're using. We're not going to use male and female. We're going to use something else, I believe. Although we might use male and females because it's easy. Let me close that. Let's see what kind of grouping variables we have. We have gender, which is easy. We have child order. Let's start with gender since we only have 30 minutes. Let's do something real easy. We're going to, don't click it, don't open it. I'm just seeing what we had. What you're going to do is create 2 groups. So up at group number 1, see where my mouse is, double click group number 1. Right up here, right under those arrows. Double click that. And we're going to create 2 groups. One is male, and then hit new, and one is female. And close. So we now have 2 groups. Amos has no clue what these actually mean, so we have to give it the proper data. I don't remember who's male and who's female, so the way you figure that out is you go back to your data set, go find the gender variable, and look at the coding here, and it says 1 is male. You can see in the values column. In the values column, it says 1 is male, and if I click on this, it says 2 is female. So hit OK. Let's go back to Amos, and in our Amos, we need to link 2 data sets now. Go to Data Files. You see now we have a group 1 is male, group 2 is female. But group 2 female doesn't have any data, so go give her some data. Recent places, data. Original. I wonder if I grabbed that from the right place. Yes, I did. Okay. So now both should have data, but it says the sample size for both is 381, but that can't be correct. So what we need to do is let's click on the male one and say grouping variable. It's this middle button here. We're going to say grouping variable is gender. Find gender at the very bottom. If you click anywhere and then hit G, it'll take you down to gender. And what we're telling it is just get data for males. So gender, okay. And then grouping value is the next button over. 1. We had 288 males, just 91 females, and 2 didn't report their gender. So hit OK. And now you can see the N for males is 288 over 381. Do the same thing for female. You're going to go to grouping variable, gender, and grouping value is 2. And you'll see 91 over 381. Anyone need assistance with that? Did we get that? Good. Okay, good. Hit OK. And now we have our data split. We're going to run two separate models, one for male, one for female. Go ahead and hit run. And then hit the up arrow when it's done. And you'll see the values. These are the values for female for me, since it's the highlighted group. But you can toggle between them. So for males, we see numbers. For females, we see numbers, and they are different. But the question is, how different? Are they different enough that it's a problem? Now, the common way to test this is through a chi-square difference test, which I don't like, not just because it's tedious and it takes forever and is very problematic if you make mistakes, but it's also an indirect analysis of group differences. Who here is familiar with chi-square tests? A few? Okay, so a chi-square test is an assessment of model fit. A chi-square, chi-square is a model fit number. And we want to see the change in chi-square and degrees of freedom between a constrained and unconstrained model. That's a chi-square difference test. And what this does is it says, well, if I unconstrain this path right here and I test the chi-square and the degrees of freedom, do they change significantly for the model? And if they do, well, then they're different here. But that's a very indirect way to assess, I think, the difference between groups. So instead, I use the critical ratios test, which gives an exact z statistic, a critical ratio, for the difference between groups for that path, for every single path. So it was created, if you go to your output, you can see the pairwise parameter comparisons, critical ratios table. You get this massive table. These are all z statistics. And each parameter now is named. I'll show you. Let me go back to, if we go to estimates, and you look at that first table, the regression weights table, you'll see that each estimate is now named. Parameter 7, parameter 8, parameter 9. And so in the critical ratios table, it takes those parameters and compares them between male and female. And it says parameter 1 and parameter 2, they're this different. Or parameter 1 to parameter 9, they're this different. And the z-score, you're just looking for something above a 1.96 on an absolute scale. So I created a tool to do this for you, because that'd be a pain in the rear to do this manually, especially with a big model. So what you do is go to scalars and regression weights table. Oh, bother, we didn't move the variances. This is why we moved the variances. So before you do this, go back to your model. Do you recall, down arrow, do you recall we moved the constraints out to the latent factors? This is why we do it. It's because the critical ratios won't be estimated for any constrained paths, but we want to know for all paths. So double click on a constrained path while the down arrow is hit. Don't forget that. And get rid of that constraint. Can you imagine having to learn this on your own? So many little itty bitty details. So I'm putting the constraint now on the variance of the latent factor. So you should have ones above all your latent factors and no ones above these right here. Make sure you retain these ones. You don't want to get rid of those. Those are important, the ones by the errors. I'm going to save this, and I'm going to run it. And now it will make pairwise comparisons for every path. So estimates, scalars, regression weights, they're all there. They're all labeled. This is the male data. If I click down here, bottom left, you can toggle between male and female. Down at the very bottom left over there, you can toggle between male and female. So I'm going to go click on male, copy this data over into the Excel tools, and go to the Group Differences tab. And I'm going to paste in A2 these regression weights. And then over in J2, I'll go paste the female data. Again, click on the female bottom left here, and then copy that table. And then over in S2, I'm going to paste that enormous pairwise comparisons critical ratios table. Make sure you do click on the critical ratios. Don't just click on pairwise comparisons. Click on critical ratios, and then copy that over. Again, my tools are not very robust. And then click the button, and something will happen. Yay. Okay, let me fix all this. Let's see. Just scroll down. Okay. So hopefully you came up with something like this after you hit the button. Hopefully it didn't throw you an error. I should relabel that. That's not a z-score, it's a z-statistic critical ratio. What this gives us is for each path, so useful is the latent factor to its items, designed to its items. For each of these paths, between each group, let me scroll up a little bit, male and female. So here are the estimates for male, here are the estimates for female, and here's the z-statistic that represents the degree of difference, the amplitude of difference between these estimates, taking into account error and sample size and all that. And so what we're looking for here is no difference in the measurement model. We don't want these to be different. We want males and females to have answered our survey, understanding them the same way, understanding the items in our survey the same way. And so we don't want differences between these loadings. It looks like we're pretty good. That one's significant at the 0.1 level, 90% confidence, not a big deal. Another one at 90% confidence. And I'm not sure about this last one here. So we don't have any issues. If we had issues, let's pretend we had issues. Let's say this was, where'd it go? This one. Let's say this was a 2.5. So significant at the 0.01 level, 99% confidence. These are different. What do we do? Well, there are articles that say you can actually achieve what's called partial invariance, partial metric invariance in this case, as long as at least one item per latent factor is not significantly different, you're okay. You've achieved partial metric invariance. So that's the rule of thumb. What if all of them are different? Well, then you have a weird issue going on, and your two groups did understand or respond to those items very differently, different patterns of responses, and that's a problem. What do you do about that? Good question. Yeah, you just wouldn't be able